MySQL is an example of a relational database engine. It manages data in multiple tables and columns, and gives you the ability to join these tables together at runtime in SQL statements. It's important to understand a few basics about the nature of databases. Data is stored in tables. In this example, data is stored for a library in a number of tables including authors, books, customers, and checkouts. Each of the tables manages data for a particular entity. For example, the authors table manages data for each author. You define the table with multiple columns. Columns, also known as fields, represent the individual elements of data in a particular entity. When you design your tables, it's very important to include a single column known as the primary key. In this table, the author ID is the primary key. The asterisk indicates this. And then each of the other columns represents a particular bit of data. For example, an author might have the first name, the last name, and the date of birth. The author ID in MySQL is commonly set up as an integer or numeric value, which means that when you add a new record to the table, MySQL assigns the next available number for the primary key column. You should design your website so that the user never sees this primary key explicitly on the screen. It's a meaningless value, so that the user doesn't have to enter the value or take any responsibility for it. It's completely managed by your website, by your PHP code, and by your MySQL database. A well-designed relational database structure is said to be normalized. That means that you don't repeat data, but instead break it up into different tables, so it can easily be joined together as needed at runtime. As mentioned previously, each table should have a primary key. The value for each row in the primary key column uniquely identifies that row, so that if you have a row, say, with a value of 5 in the primary key, there will be no other row with that value. This makes it possible to select data from the table very easily. Most tables have single-column primary keys. For example, an authors table would have an author ID, a books table would have a book ID, and so on. You don't have to use that naming convention, but it's the one I typically use. There are also sometimes tables with multiple column primary keys, where 2 or more values together make up a unique value. I won't use any of those tables in the sample database for this video series, but you will see them occur in more complex database structures. In order to join tables together, you can add foreign key columns. A foreign key column in one table would match the primary key column in another table, and that would allow you to join them together as needed. Here's a way to visualize the relationship between two tables. You create the relationships between primary keys in one table and a foreign key in another table. In this table, there are 4 columns named Book ID, Title, Author ID, and ISBN code. The asterisk indicates that Book ID is the primary key for this table. Author ID is also a numeric value, but it's not unique in this table. Instead, it's designed to join this table to another table. This table would be the authors table. It would also have 4 columns, perhaps, with column names of author ID, first name, last name, and date of birth. This table's primary key is author ID, indicated by the asterisk. Assuming that there are values in the two tables, books and authors, that match each other, you would join them together at runtime by matching the values in the author ID columns of both tables. And you would do this with an SQL statement. This is one available syntax for joining tables together. The select clause indicates which columns from each table are going to be included in the record set returned from the database. The from clause uses a join operator to link the two tables together. And the on clause indicates which columns should match each other. The operator join means what we call an inner join. That means that values will only be returned where there are matches between the two tables. You can also use outer joins indicated by the phrases left join or right join. And that means that you're including data from one table regardless of whether there's a match in the other table. Again, for the sake of simplicity in this video series, I'll only use inner joins indicated by the join operator. So this SQL statement would return 4 columns, the title and ISBN code from the books table, and the first name and last name from the authors table. These values would be returned in a single record set. and only where there would be matches between the author ID values in both tables. There's a lot more to know about relational databases and normalizing your database structures. But if you understand these simple principles, you'll be able to follow all of the exercises in this video series, and you'll be able to accomplish about 80 to 90% of what we commonly do in dynamic web applications built with PHP and MySQL.